Hello. For this lesson, we are going to learn a great topic, arc length. Before we can discuss arc length, we need to review circumference. So remember, our circle is the black part. It is that nice outer ring. This is actually the circle, right? And we measure it in degrees. But circumference is if you chose to measure the length of it. So what if I started here and I walked all the way around, right? How far would I go if I walked around this circle? That is circumference. Or if I opened it up, how long would it be? So we know that pi is circumference over diameter. Therefore, circumference equals d pi or 2 pi r. Let's do a practice problem to review. All right, so here, what are we given? Well, I'm given with a circle O, and I believe 3.5 centimeters is the radius. Okay. So using this formula, oops, I put 7, my bad. 3.5 times 2 times pi is going to be 7 pi centimeters. There you go, circumference. So let's talk about arc length. What is arc length? Well, by definition, arc length is a fraction of circumference. So if we're looking here at the diagram, you have an arc degree, right? Which is equal to the central angle. So the central angle is theta. The arc measure is theta. Now, I don't think we've talked about theta, so let's pause and talk about theta. Theta is a Greek letter of the alphabet, like pi. And we use theta to represent angles. We use it in geometry and trigonometry and in calculus and other maths. And I think sciences as well, like physics, that it just denotes an angle. So you'll see that, theta. I believe the book used A for angle, but it's the same thing whether you use theta or A. Or even if I wanted to use, I don't know, a butterfly to represent that. All right, so our arc length. So the length of the arc, so how long is just this part, right? So we can see if I wanted to know how long is if I started on this side and I walked all the way across to that side, how far? So you can see that it is part of circumference. It's just a little part for this particular arc length, not a very big part. So can we write an equation to find arc length just given this definition? Yes, we can. All right. How do we do that? Well, is means equal. Exactly. So I have arc length on this side. Is a fraction. Okay, I'm going to put that. Of means times circumference. So now we just have to figure out the fraction. Well, the angle, right, the arc, is part of the whole thing, right, all the way around. And all the way around we know is 360. So it's theta, the angle, over 360. So I could also write it like this. Instead of using theta, I can use A. Again, doesn't really matter, as long as you know what the variable represents, which is the angle of the arc you're measuring or finding the length of. So this is your equation. Now that circumference, you can use 2 pi r or you can use pi d, depending on what you're given. So let's do an example. So the direction says find arc length of AB. So AB is here. Right. And I know that the central angle is 45, so the intercepted arc is also 45 degrees. But I want to know how long that is. So arc length again, just to remind us, arc length equals the angle over 360 times 2 pi r. And I'm using this formula because I'm given the radius here. So using substitution, the angle is 45 for the degrees. It's really the arc measure, 360 times 2 pi 12. All right, so this fraction reduces to 1/8 times 24 pi. 8 goes into 24 3 times. There you are. No units, so I'm just going to leave it as 3 pi. Arc length equals 3 pi. Oh, arc length of AB. All right, here's some practice problems. You can pause it if you'd like, and then check your answers at the end. Or you can do it along with me. So the arc length of CD. So we have to find the arc measure. Arc in degrees. So the central angle is 100, so this is also 100. So arc length equals the arc degree over 360 times 2 pi r, which is 12 centimeters. So I'm going to reduce that. 5/18 divided by 2, and then 24 pi. All right, so you can use a calculator. I like to cross out my, simplify my fractions. I think it's very satisfying. 20 pi over 3 centimeters. Okay, class, please leave it in fractions. Improper fractions are not a bad thing. Okay. And especially since this is a 3 in the denominator. All right, so let's move on to number 2. So we're finding the arc length of AC, which is here. Okay, so what is that arc measure in degrees? Well, let's see. Well, this angle is not central. What kind of angle? It's an inscribed angle. All right, so an inscribed angle, if you're going from inscribed angle to arc, we're getting bigger. We're getting how much bigger? Twice. So 27 times 2 is 54. So the arc length equals 54 over 360. Oh, I forgot a radius. Okay. I'm just putting it in a radius class. We're just like, how did you get that radius? Because Miss Mendoza just made it up. I'm just going to put 6 centimeters. We're just doing it. I'm sorry. I am so sorry. So I literally just made it up on the fly. Okay, so 2 pi times 6. All right, so I'm going to simplify this fraction. I know. This is 12 here, so 12. Well, actually, let's do some math. Some arithmetic. Okay, 12 goes into this 30 times. And I'm going to divide the top and the bottom by 6. 6 goes into 54 9 times. 6 goes into 35 times. Don't forget our pi. And I said centimeters. Thank you for your patience in this one, class. Funny that I forgot the radius. Huh. All right, so this is arc length, part of circumference. Don't forget to answer the EQ. Thanks for watching. Bye.